Thank you very much, and good afternoon, everybody. I hope that I will be able to keep you awake. And I am aware that the issue that I'm going to talk about, not all the audience is familiar with that. And because of that, I will introduce some basic concepts on radioactivity and on radiation protection. So I apologize for that. The work that we have done in the Sorek Nuclear Center, it was to try to assess the radiation exposure of humans, let's say that, even if they are workers working in agriculture, or rather general public consuming crops grown in using coal ash. And we try to assess the radiation exposures due to the trace amounts of radionuclides, which are natural radionuclides that are in the coal ash. As it was mentioned before this morning, coal ash contains trace amounts of radium, thorium, and potassium-40. Radium and thorium are part of decay change that we can see it here, and as those, no, maybe. Okay, I will try to show you. Those are the decay change, and we can see that one decay change is starting with uranium-238 with a very long half-life, with the radium in the middle of that decay chain, and with all these elements inside the chain. When you are taking the coal ash, even if it's bottom ash or fly ash, you will find all of these constituents. The same is with the thorium-232 chain. And as you can see, in the change, all these different elements are included. There are solids elements, and there are also radon gas. All those elements, when they have a radioactive decay, they emit radiation, ionizing radiation. That radiation that we call alpha, beta, or gamma radiation is they're responsible for the exposure of the people that can be exposed to those elements in the even in the growing media or in the crops grown with coal ash. The average activity concentrations can be of the order of 150 radium, the same for thorium, and 250 becquerel per kilograms of potassium-40. And the consequences of using the coal ash as a growing media or as a sludge stabilizer for fly ash was assessed. And this assessment included three different things. The first one is to try to calculate the exposure of the workers under some conservative scenario. The other was the potential public exposure by consuming crops grown with coal ash. And the other one was the environmental impact. That means what was the rate of leaching of those elements from the fly ash into the soil solution. Now I will introduce two very common concepts in radiation protection. And this I am giving because, as I think Rami already mentioned, there is a misinterpretation of the real harmful or dangerous of radiation. And this was more emphasized here in Israel by the erroneous definition by the Ministry of Environmental Protection as coal ash as a radioactive waste. I believe that nobody of us will want to grow their crops in radioactive waste. Think about that. So I think these misperceptions is important to try to clarify that. when you are exposed to radiation, you can have two kinds of health effects. One is a deterministic effect. That means that you need to get a dose higher than a threshold. This threshold is around 1 sievert. This is a unit very commonly used in radiation protection. And what you get is a acute radiation syndrome. And this acute radiation syndrome, or the severity of it, it will go up with the highest is the dose. And for example, if you got about 10 sievert, 100% of the people will die because of that. The time elapsed for the syndromes to appear are a few hours or days. On the other hand, we have what we call stochastic effects. That means that what you get from low radiation doses is an increase on your risk of getting cancer. The only problematic issue is that this linear response between the dose to the probability of cancer, it was very well demonstrated through epidemiological studies done with the survivors of the atomic bombs. And the doses of those people were very high and in this area. The issue is that as human beings living in this planet, we are exposed to background radiation. And the level of background radiation is something like, let's say, in the order of this square. If we are going to use, or you are going to control the amount of radioactivity and do the radiation exposure of several uses of commodities or whatever in human life, the levels of doses will be again in this part. So the knowledge that we have is very good here, but the scientific community decided to extrapolate in a linear way to 0. That means 0 dose, 0 increase of risk. And this is the scientific consensus. The cancer, if it will appear, it will have a latency. That means it will not appear a day after you get the exposure. Having said that, I think we can go inside and I can try to explain what kind of assessment we have done. The exposure pathways are mainly two. One is an external exposure. That means the radioactivity, the radioactive material is in the soil or in the sludge or in the growing media, and it irradiates the workers while they are standing on or working in the field. This external exposure is mainly given by the gamma radiation. The other exposure pathway is the internal exposure, and this is exposure to alpha or beta radiation from radionuclides that are, let's say, in the food that was grown in those conditions. Another type of exposure can be for the workers. While they are working, radon gas is exhaled from the soil, and those people can, for example, can be exposed to them. In radiation protection, some limits has been stand, and for workers we can say that that limit is in the order of 1 millisievert per year, and if you decide to declare that specific worker as a radiation worker, this limit will be higher to 20 millisievert. And for the general public, is a very global consensus to have a threshold on 0.3 millisievert per year. Well, I put this picture because presentation without a picture can be very boring. But in this picture, you can see the different radiation exposure pathways. That means the radioactivity can be in the rock or in the soils or in the sludge and irradiate externally to the humans. It can dissolve. Those radioactive materials can be dissolved and leached out to to the soil solution, and in some cases to go down to the underground water. And all this can go through the food chain, and we can be exposed to those radionuclides. Before we get to the assessment, we have made some assumptions and defined different type of scenarios. The first one is that all the radionuclides in the previously shown decay change are in secular equilibrium. That means that if I have 1 becquerel of radium, I have 1 becquerel of polonium and 1 becquerel of lead and 1 becquerel of each of the constituents in the decay change. This is not the case, the real case. This is a conservative assumption. The other assumption was that in the sludge, for example, it contains 2 tons per dunam of fly ash, and the fly ash, the ash, is homogeneously distributed in the soil or in the sludge, and the worker is working 2,000 hours per year, which is a very high rate of working. The radon exposure was neglected, and this is because if the radon is exhaling from the soil, it very fastly it dilutes with the atmosphere, and the concentration, it will not rise, will not go up to concentrations not far above the background level. We have used conversion factor from Eckermann, and we have used maximum activity concentration of 200, 250, and 450 for radium, thorium, and potassium potassium 40. For the internal exposure and the environmental impact, we have done the following assumptions. First of all, people are consuming 1 kilogram per day of the food produced using coal ash. Again, the radionuclides are in secular equilibrium with the oil chain, and the exposure of potassium 40 was not considered at all. And this is because the biokinetic model that the body know how to balance the amount of potassium in the body. So if there is too much potassium, the body by itself will excrete this potassium, and this is not considered in radiological protection as an issue. We have used genetic transfer factor from soil to crops, and we have measured the activity concentration of the 3 constituents in crops and in milk that were produced by cows that were standing several years on coal ash. Another thing that we have done is the determination of the leaching of those radionuclides into the soil solution. For the external exposure to growing material, we have taken 2 scenarios. One, when you use bottom ash in gardening, and that means a person is standing there or walking there and so on. And we take into consideration 200 cubic meters per dunam. That means 20 centimeter height of the bottom ash. And in agriculture, as a growing media, using 100 cubic meter per dunam, which is 60% of bottom ash and 40% of organic material. The excess dose, it was very small, about 40 microsievert per year, and the limit, according to the guidelines, is around 1,000 microsievert per year. For the sludge, for the use of sludge, the fly ash as a sludge stabilizer, the situation is even better, meaning that the external exposure will be in the order of few microsievert per year. In this table, we can see different kind of crops, and we can see that in any of the crops that we have measured, we found radium, thorium, or potassium was, as I mentioned, was not evaluated, but radium and thorium was not measured above the detection limits. The regulatory limit for alpha emitter it was taken from the Ministry of Health, while for milk it was taken from the Codex Alimentarius of alpha emitters after a nuclear accident. Why is that? Because there is no regulation for natural radionuclides. So the authorities consider that, the regulator consider that it's not correct to limit something that is natural. And here you can see the table of using fly ash in the enviro as a slash stabilizer, and again, no radium or thorium was found. For the leaching experiments, we measured the leachate in the soil solution, and we found that again the numbers were lower than the detection limits, apart from radium-224, which was a little higher. But if we compare those numbers to the drinking water regulation, we can see that we are far below the limits of the drinking water regulation. That means the soil solution, it will, in a radiological point of view, it will be drinkable. Well, our conclusion is that no trace of radionuclides were found above detection limits in the crops or in the milk. The leaching from the sludge to soil was lower than 10 to the minus 3 for radium to 10 to the minus 6 for thorium and uranium. The activity concentration in the soil solution was even lower than the limitation in the regulations of the drinking water, and I must tell you it is lower than the real real concentration in the drinking water, in the underground water. And the highest potential exposure to workers and general public are far below the annual dose limits. This work was done with the collaboration of several people from the Hebrew University, Volcanic Center, Geological Survey, and some people from Sorek. Thank you.